Hi friends and my dear students. Today in Physics second volume, 12th Physics second volume, the Bohr Atom Model. The Bohr Atom Model. As per Rutherford, as per Rutherford Atom Model, already he explained there may be two limitations. One is the stability which cannot explain by Rutherford. The second one, the spectral lines. The reason for the spectral lines cannot be explained by the Rutherford. That's why we are avoiding this Rutherford atom model. To overcome this limitation, Bohr suggested some hypothesis to rectify this limitation and explain the stability of an atom and another explanation of the line spectra. That's why he considered three important hypotheses. The one is the very important hypothesis, that is the electrons in an atom moves around the nucleus. When we consider an atom, this is nucleus, then you have to consider the orbit is considered to be a circular. Then electron are revolving, electron here and the positive charge nucleus is here. As per Bohr's atom model and hypothesis of the first hypothesis, the electrons are revolving the nucleus continuously in the circular path. According to the electrostatic forces of attraction. According to the electrostatic forces of attraction. These electrostatic forces, which will give the centrifugal forces to the electron to undergo the circular motion. That's a very important assumption that he was suggested as a first hypothesis of Niels Bohr. Okay. The second hypothesis. As per the electron is in an atom revolve around the nucleus continuously. When nucleus are stable, electron are moving in the orbital itself, so that the electrostatic energy attraction, which will give the centrifugal forces to this electron towards the nucleus, as per the first hypothesis of Niels Bohr, which leads to some another important possibility to assumption that he assumed that many electrons are revolving in the orbital. Suppose you have to consider the first orbit, there may be electron revolving in the path itself. And if you consider another orbit, there may be an electron in the second orbit. If you consider third orbit, likewise you have to consider whatever may be the orbital. These are all non-radiating orbit. That's a very important. Underline the word. These electrons are revolving the nucleus in the non-radiating orbit. What is meant by non-radiating orbit? If the angular momentum of the electron, then multiple values of h by 2 pi, that is nh by 2 pi, where n that's equal to 1, 2, 3, 4, dash. If the angular momentum of an electron is multiple values of h by 2 pi, such a path is considered to be a stable path for an electron revolving around the nucleus. Here there is no emission of radiation, so that it continuously revolving the nucleus around the nucleus continuously in the orbital itself. There is no radiation. But the angular momentum that's equal to multiple values of h by 2 pi. That's a very important concept. Now, suppose, sir, how can we explain the, if there is no radiation, how can we obtain the spectral line? That's why we have to consider another hypothesis. If there is no emission of radiation, there is no continuous spectra or line spectra, which both are not possible to get if there is no radiation of an electron. But here we are obtaining line spectra. Why it was happened? What is the reason? That's the thing that we are going to see. Very important concept to explain this line spectra. Now, as per his theory, the angular momentum is L equal 1h by 2 pi or first orbit. If you say 2h by 2 pi, it is second orbit. If you say 3h by 2 pi, it may be considered to be a third orbit. Likewise, it going on. Then what happened? Then in the second part of the second hypothesis, the angular momentum of electron is the stationary orbit or quantized, that is, it can be written as integers or integral multiples of h by 2 pi, as I already told. Here h by 2 pi, here we can modify this equation. H by 2 pi may write as h bar. You can pronounce this letter is h bar, not h bar. You can pronounce this value h bar is equivalent to h by 2 pi. This is the famous important concept that he introduced to explain the angular momentum of an electron while revolving in the orbit. H bar, it is nothing but h by 2 pi. This condition is known as angular momentum quantization condition. This is a necessary condition to explain the angular momentum of quantization. Are you clear? Okay. The next point. In case, if you are assuming a nucleus and orbit, and the radius of the orbit are called r, then circumference of the orbit is called 2 pi r. Here, what he suggested, the circumference of an electron's orbit of radius r must be an integral multiples of d Broglie wavelength. That's a very important concept. Here, circumference of the electron orbit is equal the multiple values of d Broglie wavelength. D Broglie wavelength is already given by multiple values of d Broglie wavelength, since n is equal to 1, 2, dash, dash, dash. 1 lambda, 2 lambda, 3 lambda, 4 lambda. Such a way, the orbit must be there around the nucleus. That's a very important concept. Suppose, as per d Broglie wavelength, lambda, that is equal to h by p, or that's h by m into v. If you consider the electron mass is considered to be m and the electron velocity are said to be v, then the wavelength, and h is the Planck constant, then the wavelength lambda equal to h by m into v. If you are substituting this value here, then we get 2 pi r n. Instead of lambda, you have to substitute h by m into v. Are you clear? Then we have to bring these two value to the downwards and this may be in upwards. What happened? M v square r equal to n h by 2 pi. It is nothing but already told L that is equal to n h bar or equal to n h by 2 pi. This is the angular momentum of an electron is the multiple values of h by 2 pi. Whereas here, as per the circumference of the path of the electron are multiple values of lambda, so that we are obtaining this equation mvr equal to nh by 2 pi. It is nothing but angular momentum r equal to nh bar. This is a famous important equation that he suggested to explain the line spectra. Sir, how can we explain the line spectra by using these equations? Right. Now we are going to see what is the basic reason why we are getting line spectra. That we have to derive explanation for this line spectra. If you are considering orbital 1, that is 1h by 2 pi, 1h by 2 pi, 1h by 2 pi. Then the electron are revolving in the first orbit or first circular. If the electron are revolving in the second orbit, that is called 2h by 2 pi. When the electron are revolving in the third orbit, 3h by 2 pi. When the electron revolving in the fourth orbit, then 4h by 2 pi. Likewise, suppose you have to assume the energy of the electron is said to be E1. Here the energy of the electron is said to be E2. Here the energy of the electron is said to be E3. So here the energy of the electron is said to be E4. So that Niels Bohr suggested that there is no specific energy of an electron to emit the continuous spectra because it is discrete, it depends on orbital to orbital may be changed. There is no fixed energy level. That's why it is not possible to get the continuous spectra. We are getting line spectra. So the explanation of line spectra that I have to explain here, you have to keenly observe. Now, the energy difference between these two orbitals is called delta E. The energy difference is called here are delta E. Delta E. If that is, the electron can able to jump from one non-radiating orbit to another non-radiating orbit. Either 2 to 1 or 3 to 1 or 4 to 1. On such a smallest momental itself, it can be radiated the energy. Suppose if the electron in the second orbit or jump over to the first orbit within a minute second, on that second itself it may be radiate the energy so that we are able to get one line spectra. In the same way, if the energy or the non-radiating of the second orbit, electron can jump from second to the first orbit, then another spectral lines can be explained. If electron are revolving in the non-radiating orbit, there is no emission of radiation. If whether it is in the first orbit or second non-radiating orbit or third non-radiating orbit or fourth or dash. So that whenever it has a tendency to jump over to the higher energy level to the lower energy level. During that momental time itself, it may radiate the energy of difference of these two energy level. This is called radiation. That's why we are line spectra. That's why we are getting line spectra. If you write an equation for that, delta E is nothing but E maxima. We have to put E2, E3, E4. This is called E minima. E minima. First maxima, second maxima, third maxima, fourth maxima. You have to maxima 1 to E minima. E minima. And difference of this called delta E. Delta E may radiate the energy. And that radiation is nothing but h nu, whereas C equal to nu lambda or nu equal to C by lambda. Therefore, hc by lambda. This is called valuable equation that we are obtaining in the line spectra. That is a very, very important concept as per the hypothesis of Bohr Atom Model. Very important concept, but you have to clear with the help of this explanation. If you are going to study in your textbook, I think it may be not clear for you. If you are understanding this concept clearly, then you can easily go through the textbook. Now, the line structure can be obtained, or if you want to need some more example, I will give one explanation. Some other explanation. How can we obtain if suppose there may be energy level of 3, this is called higher energy level, this is called first orbit E1, E1, this is called E2, this is called E2, and this is called E2. Now, if there is any h nu is the instant ray radiation, if the electron which will absorb this energy, the h nu is nothing but the energy difference between E2 minus E1 equal to h nu. So on absorbing the h nu energy, that is called delta E absorbed by this electron, so that it bombarded to the higher energy level, so that the electron not to be in the first state but in the state of second state. It may jump over, or whenever it absorbs the energy, or it may emit the energy. Both are happened. In second stage, it will emit the energy difference delta E. It is nothing but E2 minus E1 equal to h nu. Then this electron which will getting down again to the first stage, and during this speed there may be a spectral line. Here also one spectral line. That is the basic reason that we are obtaining the spectral lines that was explained by the Bohr Atom Model. I think in the modern physics, he is the boss of explaining the spectral lines, first scientist who gave a valuable theory, hypothesis and valuable theory to explain the stability of an atom as well as the reason for the why we are obtaining the line spectra clearly. That is the Bohr Atom Model hypothesis. Very important, very important, and I hope you may understand clearly. Very good. Next, we are going to derive an expression for what are the value of orbital when the electron are revolving in the orbit. If you assume the value of Rn, you have to, and with the linear velocity Vn, then find the velocity of Vn. You have to find the value of Rn and Vn and E, energy of N. This is a very good 5-mark question. That is very important. The first one is J. Thomson, second one is Millikan experiment, third one is Bohr's Atom Model, fourth one is how can obtain, as per the Bohr's Atom Model, the radius of an electron and velocity of an electron and energy of this electron. This is a very fantastic 5-mark question. Among these 4 questions, definitely you can go and write one question in the annual examination. That's a concept that we are going to see. My friends, I want to explain one more important concept as per the Niels Bohr hypothesis. He explained the atomic structure may be explained with the help of momentum quantization. As per the quantum mechanics, the particle likes electrons in the dual nature. How can it may be explained dual nature? Now we have to consider orbit, and there may be a radius r. You have to consider an orbit like this. Then you have to draw a curvature like here. Like here. And another dotted line may also possible to draw the curvature like this. Here, this is, if you consider, this is half wavelength, this is half wavelength. This is lambda by 2, and this total distance between these one wave is called wavelength. Here we are getting n equal to 3. When you are consider the angular momentum is multiple values of 3. Here n equal to 3. Then you get a diagram like this. If you are considering 5, there may be a 5. This is called one wave. Likewise, you have to draw 5. This is called one wave, 2 wave, 3 wave. Are you clear? This one is this is called one wave, 2 wave, and 3 wave. If you consider n equal to 5, then there may be 5 wave. N equal to 6, 4 wave. N equal to 4 waves. N equal to 6 waves. Likewise, you have to explain the dual nature also as per the classical mechanics or modern physics. The Bohr explained this atomic structure by wave theory also. That's why he satisfied all the stability of an atom, the explanation of line spectra, and dual property of the particle. That's why this atom model is considered to be very important in modern physics to study about the nuclear and atom physics and nuclear physics. He is the boss of the scientists to explain all the concepts clearly. Thank you, my friends. I hope you understand clearly. Next class we are going to see.